Hi, welcome back to Circuits with Angel. Today we'll be making a 4 LED circuit. This is the 4 LED circuit. It demonstrates how resistors and LEDs work together, showing how too low of a resistance, or none at all, makes the LED burn out, and too high makes it too dim. And just the right resistance makes it shine brightly without burning out. And yes, the purpose of this experiment is for us to burn out an LED. We'll be going over how the science works in a later video, but for now, we'll just build it because it's fun to learn by doing. We will open up this box, and now we can look at what's inside. The components we need to build this circuit are two 470 ohm resistors, two 1.5 ohm resistors, two 81k ohm resistors, 4 push buttons, 4 red LEDs, and 1 jumper wire. Then we need 1 easy power supply. If you don't know what that is, I have a video about it you should go check out. Also a 9-volt battery, and a connector from the 9-volt battery to the easy power supply, and 1 breadboard. Remember to take out the breadboard out of the packaging. I'll show you how I do it without ripping the box, but you can do it whatever way you want. It has a sticker in the back. It basically says don't take off the yellow sticker unless you're supposed to. Then we're going to pick up our parts and put them back in the box to keep our workspace clean. I'll make that a bit faster. Now we're going to put the easy power supply on the breadboard. So we take out the breadboard and easy power supply, and we put the easy power supply on the breadboard. Oh, I put it on the wrong end of the breadboard. It doesn't go this way because the pin supplies negative voltage, and this supplies positive voltage. But they are going to the wrong rails. Negative always goes to blue, and positive always goes to red. So I'm going to flip the breadboard around, and I'm going to line it up with the rails, and it snaps right in. Remember, positive or plus goes to red, and negative or minus goes to blue. Now we get building the circuit. First we take out the push buttons, and we get them out of the bag. Once we do that, we put it at row 10 here, like in the picture, and each push button after that 2 spaces away from the other, which also lands at row 15, 20, and 25. Make sure the push buttons look like this, or else they won't work. Now we take out the LEDs, and sometimes they roll, so just pick them up as you go. Then we put them in the rows we put the push buttons. 10, 15, 20, and 25. Remember that the long leg of the LED goes to positive, or the red rail. The long leg is called a cathode, and an easy way to remember this is that Kathy is happy or positive. Kathy would be short for cathode, and positive is positive voltage. You should see that the LED and push button go in the same row, and that's because the push button is like a switch that will allow voltage to go to the LED from the other connection on the other side, which we will put in once this is done. I'm going to speed this up, but in case you don't know, the yellow lines highlight the row and connections the LED goes to. Now we take out the jumper wire out of the bag, and we plug it into the leg of the push button opposite from the LED. and then to the negative voltage, or blue rail. I'm going to hold the jumper wire here so you can see where the row it goes to is. I want to quickly explain how push buttons work. To understand this, we have to think about these two sides being constantly on and conducting electricity. And these two sides only conduct diagonal to the pin if you press the button. Now we want to control the LED and when it turns on, so we connected it this way. But if we wanted it to be constantly on, we'd connect it here or here. The push button can be used as a conductor or switch based on how we wire it. Now we're going to pick up the 1.5 ohm resistors, and we take one out of the package. There's another one in there in case you lose your first somewhere. If you just take the resistors out and don't put them back in, you'll get them mixed up since they all look pretty much the same. After I take it out, we bend the legs like this. Make sure the legs don't touch or else it short circuits when you turn on power, which is very bad because it damages your power supply, battery, and components in a circuit. It goes pretty much the same way as the jumper wire. Just put it into the row opposite of the LED on the other side, and into the negative rail. And we do the same thing with different resistors for the rest of the rows. This one is a 470 ohm resistor. Remember to take only one out, and to make sure no resistor legs touch each other. Make sure they go in the right hole, or else the circuit won't work. Try not to rip out the resistor. We have to bend it nicely after we take it out so they don't touch each other and create short circuits. And the last resistor is at 81k ohms, or 81,000 ohms. We take out only one and put the other one back in the package. And bend the legs so they look nice like this. We then put the side of the resistor here, and the other side to the negative or blue rail. Now it's done, so we plug in power and test the circuit. So we take the 9-volt battery here, and its connector. The shapes go on opposite sides of each other. And then they just snap together like this. If you need help, ask a supervisor or guardian. Then you take the circle side of the connector and you plug it into this port. Then we just put these two together and they give power to the power supply. Now the easy power supply has power. After you push the power button and the LED goes green, then the breadboard has power. And now we get to test the circuit. When we press the first button, the one connected to the jumper wire, the LED flashes and turns off. And if we continue pressing the button, it doesn't turn on. This LED is burnt out and will never turn on again. This LED had no resistance and created a short circuit, and that's why it failed. When we press the second button, the one connected it to the 1.5 ohm resistor, it also burns out, which is also a failure, because 1.5 ohms is very little ohms, and let too much voltage through to the LED. Now when we press the third button, the one connected it to 470 ohms, it shines brightly, which means it's working properly. Now this is the proper resistance for a LED in this circuit. When we press the fourth button, it is so dim, the one connected it to the 81 k ohm resistor, we can barely even see the light. This is too much resistance for the LED. This circuit is a demonstration on how resistance in circuits basically work. Too little or no resistance at all damages components, and if it has too much resistance, it doesn't turn on properly. And if you have just the right resistance, it works properly. Now, that's all. Thank you for watching and see you next time.